Hey everyone, and welcome to today's Explainer. Okay, so today we're unpacking a concept called the entropic governance of black hole collisions. Yeah, I know, it sounds like an incredibly dense textbook chapter, but stick with me here. By the end of this, you're going to see why it's actually one of the most exciting and, honestly, kind of hilarious plot twists in all of astrophysics. Let's get right into it.
So, to really appreciate this, we've got to set the scene. Like, what actually happens when two black holes crash into each other? Just lean in for a second and try to picture it. We are talking about the sheer, terrifying emotion of the ultimate cosmic collision. We're not just talking about big rocks bumping into each other in space, right? These are absolute titans in a deadly spiraling dance. They're whipping around each other at literally unimaginable speeds, pumping out massive amounts of gravitational waves. And when they finally merge, the forces are so violently extreme that they severely warp the very fabric of space-time. It is awe-inspiring, it's totally terrifying, and honestly, it is the absolute most chaotic event you could possibly imagine happening anywhere in our universe. But hey, let's bring it back down to Earth for a second, because you can basically think of this as the ultimate cosmic fender bender. Just picture the most massive, totally messy traffic accident imaginable, but on a galactic scale, and with absolutely zero insurance companies in sight to sort out the damages. In this scenario, our brilliant astrophysicists are essentially the extremely stressed out detectives arriving at the crash site. They're squinting at the twisted wreckage, the gravitational wave signatures, the ripples in space-time, trying to piece together exactly who hit whom, how fast they were going, and what on Earth is left over now that the dust is settling. And let me tell you, up until now, being a detective at this specific cosmic crash site has been an absolute mathematical nightmare. Which brings us to the true star of our explainer today, entropy. Now, technically speaking, entropy dictates the loss of information and the progression toward thermodynamic equilibrium. But honestly, it's basically the universe's ultimate, highly scientific excuse for absolutely refusing to clean its room. I mean, you know how a perfectly organized desk inevitably turns into a chaotic mountain of papers and old coffee mugs by Friday? Or how your headphones just magically tangle themselves the second you put them in your pocket? That is entropy. The universe just naturally prefers a giant mess. It takes active, exhausting work to keep things orderly, and the universe, frankly, just can't be bothered.
Now, we're totally used to seeing this rule of messiness down here on Earth. We see it when ice cubes melt, when sandcastles crumble, or in my absolutely chaotic kitchen after I attempt to bake literally anything. But the big, completely groundbreaking revelation we're looking at today is that the universe might be applying this exact same, deeply relatable concept to its biggest, darkest, most mysterious monsters. It turns out the very same rule that explains why a teenager's bedroom is a total disaster zone might be the exact same rule dictating the behavior of literal black holes crashing into each other out in the freezing void of deep space. How crazy is that?
Okay, so here's the core finding straight from our source material, and I've got to say, reading this gave me genuine chills. Black hole collisions may follow the entropy law. It's just absolutely incredible. We have these chaotic, unimaginably complex, terrifyingly dark entities, and it turns out they might just be following a rule we can recognize and perfectly understand. They aren't just out there doing wild, completely unpredictable cosmic math. They are bound by the law of disorder. They're maximizing their messiness, just like everything else. And honestly, finding a familiar thread of logic in something so profoundly alien, that is exactly what makes science so wonderfully beautiful.
And this builds into something wildly practical for our scientists, too. Traditionally, trying to calculate a black hole collision without factoring in entropy, it is an absolute head-spinning nightmare. It requires these massive supercomputers grinding away for months on end, trying to simulate millions of variables just to guess what the final, merged black hole, which we call the remnant, will even look like. But if we introduce the entropy law into our models, it offers this sweet, sweet relief. Because if we know that the collision must result in the highest possible state of entropy, physicists get significantly simpler remnant predictions. They can essentially just skip a whole bunch of that messy math and jump straight to the answer of what gets left behind. The elegance of this logic is it's incredibly satisfying. So two black holes collide, and absolute mayhem ensues, right? But then entropy steps in. It acts as the ultimate cosmic referee. It dictates the disorder and ensures the chaos follows a very specific, undeniable rule of maximum messiness. And by understanding the bounds of that chaos, scientists are gifted with a much cleaner, easier mathematical path to figuring out the mass and spin of the new resulting remnant. So yeah, it turns out understanding the universe's inherent laziness literally makes our astrophysicist jobs so much easier. I really want us to just sit with this concept of simplicity in the chaos for a second. There's a deeply emotional, almost poetic realization here.
Like, we look up at the night sky and we know there are terrifying, violent things happening out there in the dark. Events that are so massive and complex, they basically defy human comprehension. Yet, beneath all that terrifying fury, the universe is governed by wonderfully simple, almost humorous rules. The universe isn't just a cold, calculating machine, right? It has tendencies. It has a distinct preference for messiness. And by embracing that messiness, by understanding that entropy rules the dark just as much as the light, we kind of strip away the fear of the unknown. We replace it with a sense of intimate, deeply relatable understanding.
Which leaves us with a pretty incredible lingering thought. If the universe's most chaotic, violent black hole collisions follow a simple, relatable rule of messiness, what other massive cosmic mysteries are just sitting out there waiting for us to find a simpler explanation? I mean, what if dark matter, the expansion of the universe, or even the origins of time itself are hiding behind everyday rules we just haven't thought to apply yet? It really makes the cosmos feel a little less intimidating and a whole lot more exciting. Thank you so much for joining me for this explainer today, you guys. Keep looking up and stay curious.